Learning outcomes. After completing this section, the reader should be able to define pressure and how it is measured, define temperature and how it is measured, understand temperature, pressure, and related gas laws, explain state changes as they relate to temperature and pressure, boiling and condensing, understand P/T charts for common refrigerants, R22, R410A, R134A, understand sensible and latent heat and their measurements, discuss heat transfer methods, define superheat and subcooling as they relate to the refrigeration cycle. Perform superheat and subcooling calculations. Explain dew point and bubble point as they relate to blended refrigerants. Understand the vapor compression refrigeration cycle. Explain the differences between the low pressure and the high pressure sides of the refrigeration cycle. Discuss heat transfer as it occurs during the refrigeration cycle. Temperature is a term used to describe the speed of the molecules or level of heat intensity of a substance. As the temperature of a substance increases, the molecules in the substance vibrate with more force. As the temperature of a substance drops, the intensity of molecular motion within the substance decreases. The lowest possible temperature, minus 460 degrees Fahrenheit, is called absolute zero. At absolute zero, all molecular motion within a substance ceases and all heat has been removed. Temperature is an indication of how hot something is, but not how much heat it contains. For example, if two containers, one containing 1 gallon of water and the other containing 10 gallons of water, are placed over identical heat sources, the temperature in the 1 gallon container will rise faster than the temperature in the 10-gallon container. 10 times the heat energy must be added to the larger container in order to heat the water in both containers to an equal temperature. Measuring temperature is measured with a thermometer. Thermometers may be graduated in one of four different scales: Fahrenheit and Rankine, which are used in the United States, or Celsius, centigrade, and Kelvin, which are used in the metric system. On the Fahrenheit scale, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. On the Celsius scale, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. For scientific calculations, absolute temperature scales must be used. Absolute temperature scales are those of which the lowest reading on them is 0. On the Rankine scale, for example, absolute 0 is 0 degree R. On this scale, the freezing point of water is 492 degree R and the boiling point of water is 672 degree R. On the Kelvin scale, absolute 0 is 0 degrees Kelvin. Freezing point of water is 273 degrees Kelvin, and the boiling point of water is 373 degrees Kelvin. The Kelvin scale is also called Celsius absolute, Ca. Ambient temperature is the temperature of the air surrounding an object. The components of a residential split air conditioning system are located both inside and outside the home. The temperature of inside components can be controlled, but ambient temperature outside the home can vary greatly, affecting the efficiency of the system significantly. Page I of 32. Dew point temperature. The temperature at which condensation forms is called the dew point temperature. Air can be dehumidified, moisture removed, by passing it over a surface, such as an evaporator coil, that is at a temperature below the dew point temperature. Moisture forms on the cold surface of the evaporator coil and can then be removed from the system through the condensate drain line. Dry bulb and wet bulb temperatures. Dry bulb temperature refers to the actual air temperature of a substance, typically an airstream, and is measured with a dry bulb, ordinary, thermometer. Wet bulb temperature takes into account the amount of moisture in the air and is measured with a special thermometer that keeps the bulb of the thermometer wet. This is accomplished by placing a cotton, sock-like, wick over the end of the thermometer bulb. The wick is wetted with distilled water. Evaporation of the distilled water causes the wet bulb thermometer bulb to cool. This is because, as water evaporates, it absorbs heat from its surroundings. Since the wick surrounds the thermometer bulb, the bulb will get cooler. When this happens, it is easy to see that a wet bulb thermometer will, in most cases, provide a lower temperature reading than a dry bulb thermometer. Less moisture in the air means that more evaporation occurs from the wick and therefore more cooling occurs, resulting in a lower wet bulb temperature reading. The difference between the dry bulb and wet bulb temperatures of the ambient air is called the wet bulb depression. As the air's moisture content increases, there is less evaporation from the wick and less wet bulb depression. When the wet bulb and dry bulb temperature are the same, there is no wet bulb depression and the relative humidity is 100%. Relative humidity is the amount of moisture in the air compared to the amount it can hold under the present environmental conditions. Note, the air must be moving across the cotton wick. The wet bulb thermometer is usually made where it can be spun in a circular motion. Temperature conversion. Fahrenheit equals C times 1.8 plus 32 example. 100 degrees Celsius equals 100 by 1.8 plus 32 equals 180 plus 32 equals 212 degrees Fahrenheit. Fahrenheit equals R 460 example. 492 degree are equals 492 to 460 equals 32 degrees Fahrenheit. Celsius equals F 32 divided by 1.8 example. 212 degrees Fahrenheit equals 212 to 32 divided by 1.8 equals 180 divided by 1.8 equals 100 degrees Celsius. Celsius equals K 273 example. 373 degrees Kelvin equals 373 to 273 equals 100 degrees Celsius. Rankine equals F plus 460 example. 212 degrees Fahrenheit equals 212 plus 460 equals 672 degree. Our Rankine equals K times 1.8 example. 373 degrees Kelvin equals 373 by 1.8 equals 672 degree. Our Kelvin equals C plus 273 example. 100 degrees Celsius equals 100 plus 273 equals 373 degrees Kelvin. Kelvin equals are divided by 1.8 example. 672 degree are equals 672 divided by 1.8 equals 373 degrees Kelvin. Pressure. Pressure is defined as force per unit area. In the United States, pressure is most commonly expressed in pounds per square inch, SI. The metric, SI, system uses a pressure unit called the Pascal PA. Pressure is an extremely important concept in the HVACR industry as the operation of these systems depends heavily on pressure differences throughout the system. The pressure acting on a substance affects its physical properties, especially its boiling point. HVACR technicians need a thorough understanding of the behavior of gases in order to accurately read pressure gauges and diagnose system problems. The gas laws that deal with pressure, as well as volume and temperature, that will be covered are Boyle's law, Charles's law, and Dalton's law. In the formulas that follow, P1, V1, and T1 represent the initial pressure, volume, and temperature of the gas, while P2, V2, and T2 represent the final pressure, volume, and temperature values. All of the values in the following formulas must be expressed as absolute values. Boyle's law states that the pressure of a gas varies inversely to its volume, provided that the temperature remains constant. At a constant temperature, decreasing the volume will increase the pressure, and increasing the volume will decrease the pressure. Boyle's law can be stated mathematically as P1 times V1 equals P2 times V2. Charles's law states that the volume of a gas is proportional to the absolute temperature of a gas at constant pressure. Doubling the temperature of gas doubles its volume, as long as the pressure and quantity of the gas remain constant. Page I of 32. Charles's law can be mathematically stated as V1 equals V2 or V1 times T2 equals V2 times T1. T1 T2. Dalton's law states that the total pressure of a confined mixture of gases is the sum of the pressures of each gas in the mixture. It can be mathematically stated as total pressure, PT, equals P1 plus P2 plus P3.
And that will do it for the class today. We will start again on our next video with atmospheric pressure. Please feel free to join us at www.learnatrade.online to be able to receive the full version of this class. I thank you all again for watching. Take care and stay blessed.